Things look unnatural in reverse. That's because all natural processes happen in one direction. Sure, you can undo some processes with a bit of work or trickery, but you can't ever put every atom back exactly where it was. In the real world, all processes are irreversible. And at the root of all irreversible processes, you'll find the second law of thermodynamics, also known as the law of increasing disorder. That's what's up next on PS100. According to the law of increasing disorder, chaos is inevitable. The entropy or disorder of the universe is constantly increasing no matter what we do. This is true even when you're trying to clean up the environment by producing energy in responsible ways. For example, BYU professor Jaren Hansen and his students have developed a system that can turn a heaping mass of chaos in the form of trash, manure, and sewage into usable energy. A digester this size produces enough electricity to run the dairy and part of the surrounding community while simultaneously producing a premium compost so clean you could eat it. I mean, it's an acquired taste no one has acquired yet, but you know, you could. The process is extremely simple. All it takes is a mixing pool, a couple massive tanks filled with bacteria, and a biogas conditioner to separate the gases you want from the ones that you don't. Sounds pretty straightforward, right? It's almost like we're getting something from nothing. I mean, taking a steaming pile of manure and turning it into clean compost and pure electrical energy must increase order in the universe, right? Nope. As messy as this manure is, the output of Dr. Hansen's system is more chaotic, but that doesn't mean that it's harmful for the environment. It just means that it follows the law of increasing disorder. Just like everything else in the universe. To understand why even something this effective is producing more chaos than order, we have to understand how different types of energy stack up when ranked from most orderly to most disorderly. As you can see, thermal energy is guilty of some serious disorderly conduct. Thermal energy is just kinetic energy on a microscopic scale. When you feel heat, you're feeling the energy of particles in motion, which means the hotter something becomes, the faster and more chaotic its particles are moving. But what about when things cool down? That often happens naturally without any work, and if a cool object is in a more orderly state than a hot object, doesn't that mean we could increase order in the universe if we all just chilled for a while? Nope. When something cools down, the heat doesn't just disappear. The thermal energy has to go somewhere. When you cool down, you're really just moving your thermal energy away from your body. A refrigerator avoids this natural process, however. It sorts the air into a cool inside and a warmer outside. And while this may seem to be creating more order in the universe, it's only possible because of the electrical potential energy that it's receiving from the outlet, which it converts into more thermal energy. Ultimately, like many energy production systems, Jaren Hansen's is actually designed to create a temperature difference. The whole purpose of this system is to take the chemical potential energy from the chemical bonds within the waste and bust those bonds up to produce highly flammable methane gas, which we can ignite in our natural gas vehicles, furnaces, water heaters, stoves, and electric generators. Which brings up an interesting point. Entropy isn't necessarily a bad thing. Increasing the chaos of matter can actually be quite useful and productive. Even our bodies increase the entropy of the universe as they burn the food that we eat to fuel our lives. But if we increase entropy without thinking about the consequences, we can do a lot of irreversible damage. That's why research like Dr. Hansen's work at BYU is so important. The cleaner and more efficient we can produce energy, the longer we'll be around to enjoy it. That's it for this episode, but you'll find more science and research opportunities for BYU undergrads in the description below.